So for the last couple of days, we've been looking at adding, subtracting polynomials, and today we're going to take a look at how we can multiply polynomials. Multiplying polynomials is really similar to work that we've already done. Our focus is going to be on using the distributive property. So when we distribute, we have 1, 2, 3, 4 things that we're going to have to multiply, all by this first term of 2x to the third. But what we're going to have to be really careful about now is that we use our correct properties of exponents. If I'm going to multiply an x to the third times an x to the third, when we multiply powers, we add the exponents. And so that's what we're going to do. When I multiply 2x to the third times 1x to the third. Well, 2 times 1 is 2. And then x to the third times x to the third, we add the powers, I get x to the sixth. Then we go on to the next term. This is a positive 3x squared. So 2 times positive 3 is positive 6. X to the third times x to the second is x to the fifth. The third one is going to be 2x cubed times a negative 2x. 2 times negative 2 is negative 4, so we're going to have a subtraction there. X to the third times x to the first is x to the fourth, and the last term is 2x cubed times 5. We just multiply the coefficients. That's going to be 10x cubed. And so this is my resulting polynomial. And we should do a quick double check to make sure that there's no like terms, and there are not. We have a 6th power, a 5th power, a 4th power, a 3rd power. This would be a 6th degree polynomial. Here's a second example. Very similar idea. You might want to pause this and try to work this one out on your own. But when we go ahead and do this, we're going to, oops, I don't want a box. We're going to multiply. 3 times 4 is 12. Y squared times y squared is y to the fourth. Again, this is a negative 2y. 3 times negative 2 is negative 6. Y squared times y to the first is y to the third. And then lastly, times 1 means that's going to stay 3y squared. And that is our answer. We've got that all multiplied out. Now, they're not all going to be just one monomial times another polynomial of some sort. What I want to look at for now is how we would multiply two binomials. And one way to do this is to use a table method. I look at this first one and I see that it has 2 terms. And I look at the second one and I see that it also has 2 terms. So I'm going to set up a table that has 2 rows and 2 columns. 2 rows, 2 columns. On the edges, the outside of my table, I'm going to list my terms. Now remember, this is an x and a negative 2. So I'm going to list those like that, x and a negative 2. And so this one is an x and a positive 7. Now what we're going to do is we're going to just go row by column and multiply these out. So I'm going to look at the first one and I'm going to say row 1 times column 1. X times x is x squared. Then I'm going to stay in row 1 and do times column 2. X times negative 2 is going to be negative 2x. I don't want that to look like a negative. Now that we have finished with the first row, we're going to move to the second row. 7 times x is 7x. And now the last one is going to be negative 2 times positive 7, which is negative 14. Now, we're not finished when we get to here. This is sort of the tool that we are going to use to be able to multiply these, but that's not going to be our final result. Our final result is going to be a polynomial written out just like we did on the previous ones. So if I were to write this out, I have an x squared term, a minus 2x, a plus 7x, and a minus 14. And I got to ask myself if there's any like terms. And I see that here in the middle I do have 2 like terms. We always want to combine those down, so we get x squared plus 5x minus 14. And now that all my like terms are combined, that's going to be our answer. Now, you can notice that these two like terms that we ended up combining were right here on the diagonal of this table. And that's usually going to be the case. So you can go ahead and peek ahead and go straight from this step into this step and not have to multiply that out. Okay, let's look at one more example. 2z plus 1 times 3z plus 2. I need to check how many terms. I have 2 terms here and 2 terms here. So that's going to be 2 rows again and 2 columns. Fill in your terms. And something else is it doesn't matter which one goes on which side. Like I put the 2z and the plus 1 here. I could also have put it down this side and it wouldn't make any difference. But I just put the first one on top. This is a 3z and a plus 2. So now we're going to go row by column. 3z times 2z is 6z squared. 3z times positive 1 is 3z. Second row. 2 times 2z is 4z, and then 2 times 1 is 2. Again, now look at where our like terms are. Positive 4z and positive 3z, those are going to make positive 7z. And then the 2 is positive, so that's also going to be addition. Okay? Your ticket in tomorrow is to have these 4 examples copied down into your notes. I will see you then.